PN junction diode. The diodes are the two terminal components made from a single piece of semiconductor material which has positive P region and at one end and negative N region on the other end, which has a resistivity value somewhere between that of a conductor and an insulator. PN junction is formed when N-type material is fused with a P-type material, creating a semiconductor diode called PN diode. You can see the diagram P and N diode. So where P-type is an anode and N-type is a cathode. So next we shall discuss what are the different PNs of the diode. PN junction diode appearance. It is classified into three types. Those three types are low current diode, medium current diode, and last one is high current diode. Okay, these are the three types. What do you mean by low current diode? The low current diode means the diode are capable of passing maximum current flow up to 100 milliamp and 75 volt reverse bias without breakdown. So coming into a medium current diode, the diode can pass a forward current of 400 milliamp and reverse bias of 200 volt. High current diode or power diode. High current diode is also called as power diode. It can pass a forward current of many amperes and can survive several hundred volts of reverse bias. So there are three types: low current diode, medium current diode, high current diode or power diode. Next, coming into a VI characteristics of PN diode. You can see the PN junction diode reverse characteristics as well as the forward characteristics. So what do you mean by forward characteristics? VI means volt ampere. It is an experimental study to analyze a graphical, the electrical behavior, the relationship between voltage and current of the device. The VI characteristics of the diode is not linear, not straight line, because its resistance is not constant. Forward characteristics of diode in this mode is called as on mode of diode. P side is connected to positive and N side is connected to a negative. The following points are observed. The current in this mode is called forward current IF only due to the majority carriers. Second point, at VF is equal to 0, when the forward voltage is 0, diode does not conduct, hence there is no forward current. Third point, with a gradual increase in forward voltage, the forward current IF will also increase. So next, continuing increase of VF causes rapid increase of IF. You can see here, because diode offers less resistance. The knee voltage at the diode current starts to increase rapidly. If it is a germanium, it is 0.3. If it is silicon, it is 0.7. You can observe here. Above the knee voltage, the diode current is almost exponential growth. So coming into a reverse, these are the few characteristics of forward diode. Coming into a reverse characteristics of the diode. this is a off mode of diode. It is also called as off mode, where P side is connected to a we will observe few things here. What do we observe is the majority carriers current is blocked, but very small reverse current causes a reverse saturation current IF that flows due to the minority carrier charge carriers. You can see here initially there will be no flow of current. Once it causes a breakdown, then it starts conducting. Okay, so that is about the reverse and forward characteristics. So reverse characteristics is mainly due to the largely minority charge carriers, that is called as reverse saturation current. A small increase in IR can occur with increasing the reverse bias voltage as a result of minority charge carriers leaking along the junction surface. So these are the few VI characteristics, like forward and reverse bias characteristics of the diode. Let us look into the diode parameters. So diode parameters. So here you have 6 parameters. We shall discuss one by one. So first one, diode parameters are the rating of diode, important in circuit design and component selection. The list, there is a few list of which the diode specification is being summarized. Okay, the first one is diode parameter is forward voltage. First one is forward voltage, that is VF. What it means? First diode parameter, it is forward voltage. Forward voltage is the voltage drop across a PN junction diode during forward bias condition. It is due to majority carriers measured in volts. Okay. Forward current, second parameter is forward current. So it is a current flowing through the forward bias diode due to the majority charge carrier. It is usually measured in milliampere. Third parameter is reverse current. It is a current flow through reverse bias diode due to the minority carriers measured in microamp or nanoampere. Fourth one, reverse breakdown voltage. It is a maximum reverse voltage that diode can withstand without damage measured in volts. So fifth one, power dissipation. What does it mean? It is a product of diode voltage and diode current. PD is given by VD into IT. Okay. So here I repeat it. There are 5 diode parameters: the forward voltage, forward current, reverse breakdown voltage, and power dissipation. So next, we shall discuss the formula for the dynamic resistance. What do you mean by, what is a formula for dynamic resistance? That is given by RD is equal to del F by del IF. This is because you need to solve some problems on it, so you need to know the formula. For this, RF is given by del VF by del IF.